This lecture is on the application of the normal distributions. So last week we were talking about the standard normal distribution, which is, remember, that's the distribution where mu is 0 and sigma is 1, or in other words, the mean is 0 and standard deviation is 1. And when you are looking at the standard normal random variable, that's called z. Now in this section, we are looking at the normal distribution, but mu can be any number, and that's negative or positive, whereas sigma can be any positive number. So it cannot be negative, but every positive number it can be. So we are looking this week at distributions with other values for mean and sigma. If we aren't looking at the standard normal, we don't call it z anymore. We call it x. So here's a sketch of the standard normal distribution. If you remember, we put the mean in the middle, which is 0, and here's 1 standard deviation above, 2 standard deviations above, and 3 standard deviations above, and then 1, 2, and 3 below. And the values on the bottom are the z's, and the area underneath the curve between those values are the probabilities. Now if we're looking at a non-standard normal distribution, we might replace the 0 with whatever the mean is of the distribution we are looking at. So in this case, we are looking at a normal distribution with a mean of 25, so 25 is in the middle, and a standard deviation of 2. So 25 plus 2 is 27, so 2 standard deviations above, and then is 29, and then 3 standard deviations above is 31, and then this is 1 standard deviation below, 2 standard deviations below, and 3 standard deviations below, just like we did with the empirical rule. So the value on the horizontal axis are the x values and not z values in this, when it's not a non-standard normal distribution. And this distribution represents the weights of adult beagles for this example, which we will have many examples on this. Okay, so one thing I like to do is put both of the x's and the z values on the same sketch, where you can see that a z of 0 lines up with an x of 25 in this case, and a z of 1, which is 1 standard deviation above the mean, lines up with an x of 27, and so on. And I like to do this because it helps you see the relationship between x's and z's. Now, in this section, we use probabilities associated with x. So we might want to find the probability that a randomly selected beagle weighs more than 27 pounds. In order to do that, we are going to convert these values of x to the corresponding z values, and then find the z values in the table, just like we did last week. So the question is, how do we convert the x's to z's? Well, we use the formula z equals x minus mu over sigma. You can try some of these to see on this previous example if it works to convince yourself. So suppose we wanted to convert 27 into z. Well, 27 would be x in this case, and our mean we found as to be 25. So 27 minus 25 equals 2, and we would divide by the standard deviation, which is 2. So we have 2 over 2, which is 1. So we get 1. So an x of 27 is equivalent to z of 1. Okay, so going back. So let's do an example. Let's find the probability that a randomly selected beagle weighs more than 28 pounds. So here, I put the x's and z's on a normal curve, and here's 28, and we shade to the right since we want more than 28. And to convert 28 to z, we take 28, which is your x, and subtract by the mean, which is 25, and we divide by the standard deviation, which is 2. and we get z equals 1.5. So we are looking for the probability that z is greater than 1.5 in this case. So z would be right here, and that's 1.5. And you can kind of see from this graph that z does look like it's in between 1 and 2, so it looks like it's 1.5. So let's find the area to the right of 1.5 on the z-table. And if you recall from last week, you find the area to the left and subtract that from 1. So if we were to look at the z-table and we find the area to the left of 1.5, we would get 0.9332. Okay, so 1 minus 0.9332 gives us 0.0668. So let me just flip to this side. So 0.0668 is the probability. So the probability that you randomly select a beagle that weighs more than 28 pounds would be 0.0668. Another way of saying that is 6.68% of all beagles weigh more than 28 pounds. Okay, so now let's look at another example. Suppose the high temperatures in June follow a normal distribution with a mean of 82 and a standard deviation of 4. We want to find a probability that on a randomly selected day in June, the high temperature is between 75 and 85. Well, if we look at that on our graph with the z's and the x's, we got a mean of 82 with a z of 0, and then one standard deviation above, which is 4 above 82 is 86, and then 2 standard deviations above, and then 3 standard deviations above, 1 standard deviation below, 2 standard deviations below, and 3 standard deviations below. We sketched the area between 75 and 85, and should be able to see just by looking at this graph again that 75 looks like it's pretty close to a z of maybe negative 1.75 because it's in between negative 1 and negative 2. It looks it's over the half mark, so it could be negative 1.75. And an x of 85 looks like it could be close to 0.75. Now these are just approximations, but that gives you an idea of what our numbers should be around when we use the formula to convert x's to z's. So let's convert them. Here we're converting 75 to z. So we have 75 minus the mean over the standard deviation, which is 4. And we do indeed get negative 1.75. So negative 1.75 will be here. And then for here, the next, to convert 85 to a z, we get 85 minus the mean, 82, over the standard deviation, which is 4, and we get, again, 0.75. So our approximations were indeed true. Now we need to find the area between those two values of z. And if you remember from the last section, we found the area below 0.75, which is, let's go to the next slide. First, we find the area below 0.75, which is 0.7734 on the z-table. And we find the area below 1.75, which is 0.0401. And then all we have to do is subtract them, and we get 0.733 as our probability. So that means if you randomly select a day in June, the high temperature would be between 75 and 85 degrees, about 73.33% of the time. Okay, so now let's look at some inverse probability. And on these, we want to find the values of the weights of beagles that will give you a certain probability, the given probability. So for this example, we want to find the cutoff weight for a dog to be in the bottom 5% of the beagles. So we don't actually know until we look up on the table, but we want the bottom 5% here. Now it's the lowest, so we are shading to the left. Okay. So if we look up 0.05 in the middle of that table, you find z equals negative 1.645. We are still going to use the z-score formula to find x, and these are a couple ways you can do that. You can either take the formula and solve it for x, so rearrange it, or you can take the formula z equals x minus mu over sigma and plug in the values and then solve for x. Either way, this x equals z times sigma plus mu is the same. It's just z formula rearranged. So you use this formula, plug in sigma equals 2 and mu equals 25, along with z equals negative 1.645, and we get 21.71. So what that means is that a beagle less than 21.71 pounds will be in the bottom 5%. Okay, so that's an inverse problem. Here's another problem. So let's look back at the example where you got a mean temperature of 82 and sigma of 4. We want to find the temperature that makes up the middle 70%, so here. So just like we did last week, we take the middle 70%, so that means we have 30% out of 70%, and then that's divided evenly between the two tails. So we get 30.3 divided by 2, which we get 0.15 on both sides, on both tails. And again, we have our x's and z's down below along the horizontal axis. So if we look up 0.15 in the middle of the table, the closest z value you get is going to be negative 1.04, which means the reciprocal of that is 1.04. Now we need to convert both of the z's to x's. So x equals, so using that formula we rearranged, we have x equals negative 1.04 times the standard deviation, which is 4, plus the mean, 82, and we get 77.84. And then we do that again for the positive. 1.04 times 4 plus 82, and we get 86.16. So what that means is that there would be a 70% chance in June that you would get a day that has a temperature between 77.84 degrees and 86.16 degrees. Okay, so that's it for this lecture. I do have some more examples, so check them out as well.